Our third lesson in the Elementary Statistics Chapter 4 is on the addition rule of probability. We need to know when to apply the addition rule, and that applies when we're finding the probability of compound events where the word "or" happens to be involved. Some set notation that you've seen in your previous mathematical studies would include an upside down U meaning and an actual U meaning or. The formula for this particular addition rule is when we have the probability of event A or event B happening, we add up the probabilities of event A and event B, and we subtract the probability of event A and B happening at the same time. That is so that we don't double count. Now, some people like to use the formula, and I'll show you a way of doing that. Others like to do it in what we call the intuitive approach, which means that they just simply count up the number of ways it can happen without double counting. And we will take a look at both approaches today. In fact, finding the probability intuitively is somewhat of a skill especially as you have larger sample spaces. But let's talk about what we need to know to find probability intuitively with this particular addition rule. You need to know what a disjoint or mutually exclusive events are. Those are events that cannot occur at the same time. For example, if you had a dice in your hand, there's no way you can roll with one roll, you can roll an even and an odd number at the same time. It's impossible. A number is either even or it's odd, so you can't do both at the same time. As I said before, the probability formula for the addition rule can be confusing, so we can do it intuitively. To do this, what you want to do is you want to find your total sample space, and that becomes your denominator. Then you want to find the probability of event A and find the probability of event B, but don't count the things that you already counted in event A. You want to add those two numbers up, and that becomes your numerator. And a big hint here for those of you that understand disjoint sets, if you understand the events are disjoint, you don't have to worry about double counting because there's no way that those events can happen at the same time. Complementary events, again, we've defined the complement of A bar, as the outcomes in which event A doesn't occur. These events obviously have to be disjoint because how can A happen when what isn't associated with A happens? They can't happen at the same time. It's also absolutely certain, as we've said before, that event A is going to occur or event A is not going to occur. Knowing this, the probability of event A or event not A happening is adding up those two probabilities, and the sum of those will always be 1. No matter what event you're talking about, the answer to an event happening plus the probability of the event not happening will always be 1. Because of that formula being the case, we can change it around a little bit, and we form the rule of complementary events, which means 1 minus the probability of A, as we've stated, is equal to the probability of not A occurring, and 1 minus the probability of not A is also equal to the probability of event A occurring. Let's take a look at some examples here. This table shows polygraph results. Okay. In this case, what we want to find the probability of a correct interpretation by the polygraph and the probability of an incorrect interpretation by the polygraph. Okay? In essence, how to read this chart is when it's a positive result, it's a lie, So we want positive and yes. Positive and yes are correct, and no and negative are correct. Whereas positive and no would be incorrect, and negative and yes would be incorrect. So when we take a look at the probability of correct, what we have here, again, as we said, would be true positive or true negative. So therefore we have 42 plus the 32 is 74. And out of the total events that we had were 98. So the probability of a correct event is 74 out of 98. For incorrect, we can use the law of complementary events. We could do 1 minus 74 over 98, which gives me 24 over 98. Homework in this section is textbook pages 156 to 159, numbers 2 to 40 even.